if you have visibility into user reviews and feedback, if you have visibility into price points and generally the cross-axis of lethality and price, that sorts itself out. I love the idea of the marketplace. My business, we're set up for this new style of consumer-driven warfare, commercial technology-driven warfare, whatever you want to call it. And we want to compete against those who are slower against us, right? So let's have at it. I don't know what AeroVironment makes that's compelling for the future. Maybe they're a new fixed wing, but the Switchblade, that's old news. And if that was on a marketplace and I can compare the Javelin versus the Switchblade versus a small FPV and see that, allow 06 officers and up to make that purchasing power, I think that's the beginning of what really is going to drive the industry.
Welcome to The Vertical Space, the podcast at the intersection of technology and flight, featuring deep dives with innovators, early adopters, and industry leaders. We are your hosts, Jim Barry from Celerity 05 and Peter Shannon and Luka Tomjanovic from Radius Capital. At Celerity 05, we believe that breakthrough air transportation capabilities come from leveraging current and emerging technologies, and that companies achieve profitability through relevant technologies, strong teams, and a deep understanding of the aviation market. Connect with global aviation experts at celerity05.com for feedback and recommendations to chart your path to success. At Radius Capital, we invest in early-stage deep tech that redefines what is possible in aerospace. We partner with founders building next-generation aerospace capabilities, from advanced design and development tools to the digital transformation of the flight environment, novel use cases and forms of flight, and the software and systems that make them possible. If this describes you, reach out. We're excited to connect. All right, let's dive in. Welcome to episode 101 of The Vertical Space. In this conversation, we sit down with Ryan Gury, co-founder and CEO of Performance Drone Works, PDW. We explore insights from the war in Ukraine, how spectrum and radios are evolving, including Ryan's bold claim that, quote, radios are gone, how commercial technology is reshaping aerospace, the current state of autonomy, lessons from winning government contracts, and much more. With over a decade of experience as an inventor, entrepreneur, and drone expert, Ryan has been a driving force in the small drone industry. In 2015, Ryan co-founded the Drone Racing League, DRL, establishing it as the world's leading professional drone racing property for elite pilots. As CTO at DRL, he spearheaded the design, engineering, and production of custom-built racing drones and developed groundbreaking radio technology to counteract jamming and interference. The technological innovations under Ryan's leadership attracted significant interest from the U.S. Department of Defense and the broader defense community. This led to the establishment of PDW in 2018 to meet the specialized needs of military and government agencies. In 2024, Ryan's innovations in anti-jamming radio technology earned PDW an award from US SOCOM. Additionally, the U.S. Army selected PDW's flagship C-100 quadcopter to support its company-level small UAS directed requirement. Ryan holds 10 patents for pioneering drone technologies and has been recognized with 2 Guinness World Records: fastest battery-operated remote-controlled quadcopter and longest endurance for electric-powered quadcopter. Enjoy this fascinating conversation with Ryan. This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. Ryan, welcome to The Vertical Space. Great to have you on the show.
Thanks. Looking forward to it. Thanks for having me.
Absolutely. We're looking forward to it as well. We usually start by asking the first question if there's anything that very few in the industry agree with you on.
First and foremost, you have to look at like the basics, where there hasn't been this much change in this space since World War I, World War II, right? And we all watched in the 2 big films, 1917 and Band of Brothers, right, where the first tank crossed the line in World War I, and that was the beginning of armor. And we saw Captain Winters in Band of Brothers deliver a very comprehensive strategy to take out artillery that was hitting Omaha Beach by use of maneuver warfare. And things have largely been the same. There's been air superiority and long-range strike platforms, but for ground wars, that's kind of been the way that we have delivered ground wars for some time. And that's been completely changed on its head, I think, over the last 2 years, as you can strike a target 10 miles away from under the cover of a foxhole, right? I think that there's also different ways that wars are waged, and I'm a civilian, so I think that's important to note. Like, I'm a technologist and I'm a civilian, so my word only goes so far by what I see. But you can draw conclusions, like if the U.S. were to wage war with another country, would probably use just a ton of tomahawks and medium and long-range precision fires, and that's going to be a pretty heavy-handed, lopsided attack, right? Where we'll come away with what we saw in Iraq, where it was very lopsided and we moved too quickly. But I think in any situation where there's a ground war, that boots on the ground and infantry units are covering land, I think you're going to see small robotics in the same way that Ukraine has, right? And Ukraine is up against a pretty modern adversary, and they have all the NATO equipment, most of it. I think as of today, they get the Tomahawk, right, to really attack the Red Army and defend their motherland, and they choose a drone the size of a dinner plate to do most of their work. And there's different combinations and configurations and reasons and rationale, but at the end of the day, you get 45 minutes to place a sizable munition in a square inch of a target from undercover. And you can do that in a hole in the ground, right? And compared to something like a javelin, where you got to stand up, point and face the enemy, you get one shot, and it's up for that munition to strike on top of the tank and so forth. But it's a very different style of warfare where you're conducting missions through a robotic edge device that's completely different than anything else. I also think like the time on target, like the hunter style approach of FPV, where you can fly around and identify targets, do some ISR, and if you decide to strike, you can with incredible precision, right? And we watch all the footage of FPVs flying down trenches, finding tanks and armor inside dugouts, slowly finding their way in tunnels, and so forth. Like, it is just an incredible amount of precision, and you can do that from safety. I think that's just the game-changing thing there. I would much rather have a drone, want to have a drone than an M4, right? And I think that's going to continue into the future. And I think the thing about Ukraine is that it's not stationary, right? I think people like to just draw a line and say, oh, this is what Ukraine has, this is what they have today. And if you really want to peel back the onion, what's happening is commercial technology, the way that we develop technology to support B2B and B2C and industrial applications, is eating aerospace. So commercial technology is eating aerospace. And I can go get an Apple Watch, right? And I can get that for like $300 on eBay. Aerospace will never be able to make that. I don't care what Skunkworks thinks they can do. That Apple Watch is pretty damn hard, especially at that price point. And I think in a lot of ways, that's what we see in Russia, Iran, the Houthis, and what, we'll see in the future, where small systems that are developed with commercial and consumer-minded design approaches are going to have capabilities that aerospace does not yet have the capability to deliver.
Ryan, let me follow up on your earlier point about maneuver, because I think it's a really important one. And yes, you're right. The way that Western militaries fight is around maneuver. And so one of the common criticisms about extrapolating what's happening in Ukraine to other future wars, that discussion centers around maneuver and how the US military, for instance, would utilize maneuver and not get itself engaged in this trench style warfare. But here we are seeing a war in Ukraine where maneuver is dead. My question to you is, what replaces it as an organizing principle of warfare? Is it mass and attrition? Is it autonomous systems? Is it dominance in the information domain? What do you think replaces maneuver?
I don't know. I think West Point, the printers must be running, right? And myself and my chairman, Tony, and a few others have been engaging the dean over there to talk about how they're looking at doctrine and what they're thinking about in the future. But I imagine it's an evolution of maneuver warfare. And you got to remember, these drones hit targets 20, 30 miles out, right? So I think there'll be an evolution of how that's conducted and how they integrate in new combat systems and how they leverage robotics on the edge. Whether it's a shot-head or a dinner plate-sized drone or a fixed wing that can do surveys, identify enemies, and strike them, there's going to be a spectrum of solutions that will always be moving. And I think that's why velocity and iteration is the key to success for the future battlefield, where requirements are changing day in, day out, and they'll continue to for decades. And there's not going to be, a very stagnant way of doing this, and it's just going to change so much. You have to kind of stay ahead of the curve constantly and develop an industry that supports that, and procurement that supports that, and marketplace that supports that, because this is the very beginning. It's the first chapter of robotics that are lethal, that act without humans in the loop, that do things we've never seen before. And I think everybody wants to draw a conclusion, but it really is just a new style of combat development, or a new style of procurement and developing solutions in the space, because we're at the very beginnings of this. And it's going to speed up, not slow down. In 2 years, right? 2.5 years, it's been the first time a small drone was used in Ukraine. All of this happened in the last 24, 30 months, right? And it's going to continue for the next 1,000 months. So taking a step back and looking at that, saying, oh gosh, all this is changing. It's going to continue to. How do we adjust the way that we develop combat systems? How do we adjust the way that we develop doctrine? How do we adjust the way that we work with our customers and our warfighters and our contracting officers and program management officers? All of that has to evolve. And we're seeing the beginnings of that. So I like to say that commercial is eating aerospace. But when you look at commercial, it's a very fierce, competitive, capitalist architecture to support that, right? Like if you don't make the next iPhone, Samsung's going to come after you. And the consumer body being on Amazon or having people rate you and tell you how effective, like I would love to know what the effectiveness of an FPV from Ukraine versus a Switchblade is, and the price per kill and the price per lethality and how you scale that. So like in the consumer world, you're up against, you're always on defense. You get a product out there and the next day people hate on you and you got to change it. You got to fight for it and you got to continue and iterate, and you have your R&D and your IRAD, and it goes and goes. Look at Apple. How do we develop weapons like that? How do we sustain an industry to support that? I think as of today, the US DoD has bought like 3,000 small drones, right? So I think there's a lot going on.
Hey, listen, one thing you've mentioned is there's a lot of what you're saying. Boy, how things have to change, right? All in the last couple of years. And whether everyone agrees we're going to take all the lessons from Ukraine and it'll apply to the next battlefield, but you're clearly right, massive changes. You've mentioned drones are like ammunition. And I think it ties in with what you're saying right now. Explain that a bit.
Yeah, so I think the way that we develop like an artillery shell is fairly standardized. They're one-time use. Everyone tells me we have arsenals of 30 millimeter mics to be used, right? And they're designed to be, thrown away. And I think that's part of the problem with robotics. Like you have to design your drones to be single use, which means things like you got to use injection molds and the electronics have to go together like Legos. You have to be able to make 10,000 a month. I think the other problem, though, is what I was saying, is how you adjust the manufacturing line as the product is enhanced. So you have not only the complexities of mass manufacturing and looking at weapon systems as consumer technologies, right, and treating them as such so that they're really inexpensive and you can treat them like scale, right? But also you have to refine that line continuously, because what we make today is not going to be useful in 2 years, and you have to treat it as such, right? So it's a very complex problem that we're about to face, right? We have to support an industry and pay for it. Billions of dollars need to be there for lots of companies to work on this. You have to treat these products, these combat systems, essentially these javelin systems, as single use and only a few $1,000s each as munitions. And you have to evolve them really fast over time, right? And those three big things is what the industry will be up against in the next decade.
I mean, those are some profound differences that we're then dealing with, because when you describe the battle space, we have, number one, the reemergence of mass as a really important factor and the economic balance of executing the fight. And that obviously plays into magazine depth. Then we have this dimension of the rapid evolution of this, having this side of it's really machine versus machine and constant one-upmanship in terms of innovation, in terms of, okay, well, there's a fiber drone, and then how do we defeat a fiber drone, or how do we use a drone to intercept a Shahed? It becomes this really fast iteration of machine versus machine. And then what you just mentioned is these systems, many of the smaller systems, are treated as munitions, not as equipment that you would sustain for decades. But the difference being that they will go obsolete sitting on the shelf and potentially go obsolete very quickly on the shelf, unlike the munitions that we are accustomed to stockpiling. And so, from a pure procurement standpoint, how do you balance the idea of stockpiling and maintaining an industrial base to produce the stuff when you actually need it versus the fact that at the very least the firmware on board those systems is going out of date, and equally likely the hardware itself is becoming obsolete in a matter of months while it sits in your stockpile? How are people dealing with these factors as they think about, okay, how do we stop talking and start taking action to be prepared for what's around the corner?
Great question. I think first and foremost, like we can't forget who we are. And, we invented 3D printing. We invented Apple, Microsoft. I mean, there's no Lady Gaga anywhere else in the world, right? That's for a damn reason, right? And I think we just have to look across the aisle at the other stuff that we're doing in the space. And Apple is the first company in the world to do essentially mass scale manufacturing of robotics. If you really think about it, they just don't have actuators, but those are pretty decent clamshell computers. And I think we sold a lot of the manufacturing capacity off to China in the last 10 years. They've gotten pretty damn good at it, but I don't think that's something that's too hard to come back onshore, especially as automation goes up. So I really just think that we have the model, right? It sits in our consumer world, and we have to learn the lessons of that. I think for it's product development. We're making products, and they're lethal, and they have to abide by safety and security restrictions and requirements. That's it. Everything else we're the best at. There's nobody else out there doing chips, doing electromechanical work. Like, it still says designed in California. Let's not forget that. Okay? And I think that we just have to change the way things have been done. For a long time, aerospace has been making Global Hawks and SR-71s and satellites, and they've held this exquisite crown, and the style has changed. That's all it is, and partially due to us. And I think that if we really want to behave as a modern product company, we have to procure and act like one and design toward one, right? So for us, when we design robotics, we're thinking about a BOM cost of thousands of dollars. Our FPV is like hundreds of dollars, right? And we have to work backwards from that. But so is the iPhone. So is my Apple mouse. So are the speakers that I use, right? It's just a different style of design. And I think that's why the deep tech space is so interesting now, because you have a lot of startup people in the space doing things differently than they were in the past. And that's disruption, right?
Ryan, what you were describing is on the product development side, but I think part of Peter's question was, how does the DoD procurement world need to adapt in order to accommodate these quick to obsolescence products and not stockpile something that in even 2 months will be not usable?
Capitalism. You can see Hegseth's memo around the marketplace and the ability for officers 06 and up to make purchasing power decision, and removing all the red tape around small robotics. Look at Brave One in Ukraine, right? Or heck, look at Walmart and Amazon. If you have visibility into user reviews and feedback, if you have visibility into price points and generally the cross axis of lethality and price, right? That sorts itself out. I love the idea of the marketplace. My business, we're set up for this new style of consumer-driven warfare, commercial technology-driven warfare, whatever you want to call it. And we want to compete against those who are slower against us, right? So let's have at it. I don't know what AeroVironment makes that's compelling for the future. Maybe their new fixed wing, but the Switchblade, like, it's old news, right? And if that was on a marketplace, and I can compare the Javelin versus the Switchblade versus a small FPV and see that, allow 06 officers and up to make that purchasing power, I think that's the beginning of what really is going to drive the industry.
At the same time, if I can push back on this, I agree with the general direction, but I also understand how the DoD would not want to take on this third party risk and depend on the marketplace to meet the surge in demand that it will need at some point, right? There has to be some level of stockpiling and inventory to be held. Yet at the same time, we know that obviously it doesn't last from a technology and relevance standpoint. And so, what's the fix for that?
Hey, Ryan, can I volunteer something that you've said before?
Sure.
Talk a little bit about, and I think it applies, talk a little bit about General George's transformation and contact, because I think I've heard you talk about it in some other sessions. I think it probably applies here. And I think it's describing some of the dynamic nature of the battlefield and a dynamic way to be able to address the needs of munitions and the like. Does it?
Yeah, so look, I think there's 2 points. To Luca's point, I don't know what we do to solve the arsenal buildup. We certainly can look to lessons by Iran, Russia, and China, who have the industry to support hundreds of thousands, if not millions, of Shaheds, right? And we can go online and we can see the factories in North Korea. We can go online, we can see the factories in Russia. We can go online and buy all the parts to a Shahed right now off of Alibaba. I'll get you a GPS constellation, a scooter engine, two-stroke, and I think right now, if you go to AliExpress, you can just buy the body of a Shahed. That's very evident of a full-fledged industry moving. And the Shahed changes. We see that day in, day out. I just saw a new GPS constellation this morning. They have jet propulsion. They have different VTOL options. They have the Gerbers coming in. There is a ton of iteration in the Shahed product, and they're running it like a modern commercial product company, right? They're sharing resources. They have different factories. They have different block models. You can follow it. It's fascinating. And they also operate in swarms, like the only group out there doing actually like proper swarm techniques to overrun our air defenses and so forth, right? So I think in terms of like what an arsenal looks like in the future, I think the Shahed is probably an early glimpse of that. But it is an engine, and it is not stagnant. There's a new GPS constellation, a Shahed every 2 weeks, right? So they can remove the GPS problem. And there's different power plants, there's different styles, but like, man, is that an early glimpse? Jim, transformation and context is an early glimpse to how the Army's going to move, right? We have these brigades all over the world, different feedback. We can ship a fleet to each one, and they give us feedback in 4 to 8 weeks. We can make that change on the line immediately, and that is a very early glimpse into that iteration cycle. They call that transformation and contact to reduce the technology gap, to speed things up. So the Army at large knows there's a velocity and iteration problem and knows that there is a need for higher iteration. The HEGSEF memo as well, O6 officers are up, having a marketplace, removing red tape, another indication that this is transforming. And I think that's going to continue into this year and next, right? Where we will see procurement, project management bodies, and transparency from the vendor to the customer be uplifted, right? I should be able to have a user on my end tell me I'm terrible immediately, right? And be able to make that change to the product and fix it. And when I worked on other products, whether they be apps for Kohler and McDonald's and MLB, we put an app out there. You get a review back in 15 minutes. You can make that change, redeploy that, and fix that in due course time. And I think that's the name of the game. You see Tesla doing that at massive scale, right? Where my Tesla is different from my friends who bought it 2 months earlier. He has a front cam, or he does not have a front cam, and I do. Making changes live on the line, changing the way that block models, ATOs are done. So we're working quickly with our ATOs and DIU to get them done on a quarterly basis, right? Or I have 4, 5, 6 versions of the craft out at a single time. That's insane to some people, right? And I think that's where things are going. And I think the Army, they haven't changed this much since World War II. They're doing a lot in a little, right? So if anybody's worked in a big corporation, right?
So with this much change, you're talking about the Army here. How does that affect you at PDW? How do you deal with that change? How does it play to your strengths? And what kind of environment does it make for somebody who's trying to anticipate the needs?
Well, I think it's getting a lot easier to cross the valley of death, and it's going to continue to. We've been working in this.
Which valley of death is this?
The valley of death before you get your first check in the DoD, right? So We had to raise a ton of money to build a team, staff the team, get a headquarters, develop a thesis, generate requirements, prototypes, flying demos, compete, exercises like Vertex and A, get feedback, make new drones, manufacture them at scale, get into a program of record, get down selected, make all those drones, buy all those cogs, wrap them all up, ship them all over the world, and then you get a check, your first check. All right, that is a decade in the making. That is hundreds of pitch decks to manage expectations, to show the growth model, right? All to get your first check. And that meant that groups like my group is far and few between. There are literally no drone makers in America. Some do that China is taking away the consumer model, right? So that you can't have a commercial model, so you can't have your drones at Best Buy and selling and supporting that. I think some of that is the procurement cycle is not made for this era, right? They're made for intercontinental ballistic missiles and F-35s, and righteously so, right? Like that's a very big, expensive investment. You got to get it right. And I still think we're living off of a lot of rules from McNamara during the Cold War, right? So there's just been a dearth of competition in the space. It takes a mind-boggling amount of capital to get in. And I think once these barriers have been lowered, like we're going to get a lot more competitive groups in the DoD making money, building a team, getting good, getting IP, right? Like capitalism should, right?
Ryan, have you heard any success stories in the post-Hegseth memo that would support this vision of streamlined procurement and any O6 and above being able to go to the equivalent of the marketplace and order stuff? Is that happening, or is it still kind of preparing?
It's still preparing. Like, so PEO Aviation and PM UAS have a change of hands. There's a ton of logistical items to get in place. They have to get the marketplace up. But I see evidence of all that. Some I'm privy to, some is you hear through the grapevine, but you can see the need for it, and it's going to take them a little bit of time to stand it up, but it's coming. And
what will this marketplace look like? Do you think that there's a good vision for it? Will it be government owned and operated? Will it be some third party?
I'm sure, normal civilians won't have access to it, right? That would be a little crazy. I'm sure it's going to be very secure, but I'm sure it's going to follow the very common patterns of e-commerce that we all know and well. Taking items and putting them into a cart and selecting a way of paying. I want to see user reviews. I would love to see performance specifications, right? But all the great things about capitalism should surface in that marketplace eventually.
Switching gears a little bit, but you're following the developments in Ukraine very closely. What's the latest wave of technology and how technology is being employed there on the small UAS side of things?
Oh my gosh, so many things. I could talk about this all day. I think sleeper robotics is a huge one. You see that on small ships. We saw that in the Operation Spiderweb. I think that sleeper robotics that stay dormant, come online when necessary, are going to be huge. Small solar panel, small timer. I currently have a webcam in my front yard. Lets me know when people are coming and going. Solar powered, never need to charge it. It's awesome ISR device, right? And drones are going to work the same way. They will be intelligent landmines. They will stay in the trees. They will stay on the side of boats. They'll be shipped in shipping containers. They'll perform actions on the edge. And landmines operate in the same way. When a sensor is triggered, right, they go off. And I think it'll just be a more highly advanced sensor. When a sensor sees a certain target or a certain condition is met, it'll deploy a series of actions. And that's sleeper robotics. And I think that is going to be tremendously powerful and scary.
Yeah, it's like the landmine that steps on you.
Totally. And we already see it now. I like to use the word autonomy over AI. I think autonomy is a huge important word, but AI gets a little silly. The Ukrainians and the Russians are already deploying assets that deliver the whole mission of lethality by themselves. Fly over this area, conduct a survey, use whatever computer vision model that is available. And they probably use YOLO because that's open source. But in the US, we have Athena, Turbine 1, Project Maven. And when you meet the conditions of a bad guy or armor, strike them. That's happening now with thermal cameras. and thermal vision models. We already see the beginnings of sleeper robotics now. Drones that sit on the side of the road. Drones that sit on the side of the road with solar panels. So you merge that all together and you're starting to see what the beginnings of AI and autonomy will be. And whether they're standoffish and generally made one at a time, or they mesh together and make multi-agent missions occur, right, like the Shawheads. I think that's just going to be one of the many ingredients driving combat systems into the future.
You could really see sleeper robotics as a concept blurring the lines between peacetime and times of conflict, and they could be used across a spectrum of timeframes and circumstances.
Oh yeah. I mean, we do that with code now. I'm sure
Yes.
ourselves and our adversaries have many zero-day injections that they could utilize to
Everyone's got a
overcome
gun
all
pointed at
different
each other's
types of.
heads in the cyber domain and also
Yeah,
in the orbital domain.
absolutely. And I'm sure there's a huge library of 0 days that the Pentagon has access to, right? And so does China. We're going to see the physical manifestation of that, where cyber warfare or lethality is dormant until necessary. And there's not a lot of people working yet in that space, but I can see that space being one of the most dominant growth industries in combat system development. We could talk about radios for a while too, but I think radios are just gone.
Unpack that.
Yeah, so I mean, you can go on ChatGPT or you can bring them up yourself. There are dozens of jammers operating on the edge, and they're called things like the Zytel or I'm looking at my list now, the ZAR 3, the Lear 3, the Bucco AD, the Pol 21, the Noda, the Netline. They're seriously just software-defined radio systems, mostly built by analog devices with a massive RF front end, putting tons of energy into the spectrum. So if you want to strike an enemy and your drone is flying far away, and that drone gets close to a jammer that has more energy somewhere around your band, you lose contact with it. There is a reason why the entire front line is crisscrossed with fiber optics. It is very easy to jam a radio, especially if you have a wide spectrum jammer. And some of the systems, if you want to change spectrums, you have to change out the module or change out the antennas. So the idea of a radio system operating anywhere near close to 50 of these jammers, China, Russia, whatever, it's never going to work. And all these radio companies were built on like compliance, like the FCC relegations or amateur radio bands. They're still operating on like 1.3, 2.4, or 5.8, or roughly around it. But no one is making. The solution is either you make use of the entire spectrum and you have an array of radios, or you use fiber optics. We're currently selling fiber optics in our FPV, right? And I don't really see a lot of energy being pushed toward radio solutions that counter these systems. I think the other problem is that our most radio jamming solutions, like Iridium Shorts or a handful of radio jammers that you see from top primes, they're just doing protocol sniffing against a known library. So they look for a certain protocol, they find that protocol, and they stop that protocol. But the Russians just wait for a drone to get close, and then they shut down the whole spectrum. And they do it with like a little toggle. You see jammers on donkeys, jammers on people, jammers on tanks. You see these big jammers across big vehicles. They just go from literally 600 to 6 gigs, and they just stop half of it with like thousands of watts of energy in all directions. So for 10 seconds, when they hear a drone, they click it. That part of the spectrum goes down. The drone falls out of the sky. They turn it back on. That's it. The idea of wireless links in a battlefield environment like we see now is, as we see in Ukraine, I think that's why we see all the fiber optics. And I also think like a lot of the learnings from this are allowing for directional jamming and GPS jamming. You go to gpsjam.org, I think that's it. You can see how the Kaliningrad region basically stops GPS all the way from like Germany to Finland. It's just not sexy, so no one talks about it. You don't see a small drone with an RPG on the front of it. But it's a core ingredient to success. Otherwise, everything's going to be lethality without a person in the loop or fiber optics, both of which have their pros and cons. But what happens to our remote systems when you don't talk to them? Or if you have to tether everyone with a piece of glass, right? How are we preparing for that? These jammers from Russia and China, they're not sophisticated. You can go look them up on ChatGPT and see how they work and see how much energy. There's brochures and spec sheets and conferences that you can go to and learn all about them. It's just putting energy into the band. That's it. So like,
Isn't it tremendously difficult though to put enough energy into the entire set of frequencies that people might be communicating on, to do that simultaneously? Doesn't that become just infeasible at some point, technically or economically?
I mean, if you look at these jamming systems and you look at how much energy they're using and the bandwidth they're using, it's an extraordinary amount of energy being put into the band. And they do it across many different radios at once, right? So, yeah, if I got one radio and one RF front end and one module, sure. But then they just make 12 of them and put them together. So like they're using an array of jammers, and it's not that scientific. So they make these systems. They have 10 different power amplifiers, 10 different RF front ends. They're basically putting Gaussian noise into the band. And they have a spec GAN sometimes where they can see where energy is coming from or what frequency they're moving on. But it's just really easy. They just momentarily just stop all radios. And I think like we've always come to the conclusion, well, they can't just do that because then they'll stop their own communications. Well, yeah, if there's a bunch of drones in the sky, they're going to click it and turn it on, right? And then you just turn it off. Now you can talk on your man-made radio again.
Right. I mean, it works, but it's also very stone-aged type of operational deployment. You take down everything that flies, including your own assets. And oh, by the way, if the drones are using LTE, then you wipe LTE or cellular networks to the population that lives around it and all of the other government users of it, et cetera, et cetera. So it's
for a moment, though, like there's even during this podcast, there's going to be periods of time where we're going to have a little hiccup here, right?
but the drones are flying constantly over
They'll do
across the
position
battlefield.
hold.
So.
And like if you have most of the drones are like, I think that's the thing about it's only around you. Like when you set off that energy, it's only when drones come close to you, right? So it just depends. And like, look, at the end of the day, everyone's flying with fiber optics, right? And man-A radios are still used on lower frequencies because they don't. I think the frequencies for man-A radios, like the super low stuff, cellular is in 700, 960, and it's just what's happening, right?
Where do you think this leads? Is this the end of traditional comms or repurposing of it or being more disciplined about its use, or are we facing a completely new RF doctrine?
I mean, I think it's just a continual game of cat and mouse. It just never ends. But I mean, I want to hear what Ryan thinks.
Yeah, I think I agree with that. It's going to be SATCOMs, it'll be directional comms. We should see directional antennas on gimbals with drones that face the end user with a very small field of view. Shield AI was using a laser beam from a ship, right, to get over the horizon. So, and they had to fly at high altitudes, I'm assuming, to do that. So it'll be a smorgasbord, right? I can also find signals way faster. There's all types of groups coming out of the space, all with the help of analog devices, doing direction finding. And I just think that the same way that like the aerospace primes are being disrupted, we'll also see the signals space gets disrupted as well. And that includes links or anti-links, right? We still have yet to see Seek on Jam, which is on Twitter something that we really want to see, which is a small FPV that, I don't know, has the same idea as a harpoon or a penguin or something like that, and can identify a jammer and strike it just based off of DFing, right? We'll see that soon. And it all goes back to the thesis. Like, look, like nothing is stagnant. We need an industry to support incredible iteration and competition. And I think that's where a lot of people see eye to eye. We need a marketplace. Everyone should have access to purchasing power. We need a user base to be able to give feedback and talk shit. And we need a customer who's going to spend, right? I think that they're kind of waiting to really deploy the purses until it makes sense. The last thing I think the DoD wants to do is buy an arsenal of drones that don't work. So I think that the DoD is going to be smart. They're going to want to deploy capital where it's sustainable, not look silly. I think the marketplace and removing the red tape for O6 officers and above is a huge portion of that. I think they have to reformulate and retrofit the PM offices to support that, because that's a huge amount of change for them. And then I think they're going to set up a system for fast iteration. I think that recompetes and program of records are going to happen every 3 to 6 months if they exist, and I think everything else is going to be through the marketplace. And then once that's all stood up, I think that's when you're going to see the purse strings or the capital really getting deployed to the space, right? I think that PBAS is really badass. That is the new program of record. A handful of people have competed in it. It is thoughtfully named the Purpose-Built Attributable System. That is a quadcopter of the future. Completely modular. Change out munitions, change out cameras, change out radios. The price point is a few $1,000s. Super lethal, anti-armor, anti-personnel. And they're going to recompete that every 3 to 6 months, indefinitely.
I want to quickly follow up to one of your just recent points on Spectrum when you mentioned array of radios as a way to counter the proliferated jamming. Do you mind unpacking this a little bit?
Yeah, so there's like the electromagnetic band is like a rainbow. You have all different colors. And instead of colors, you can call those bands. So I got the yellow band, the green band, the blue band, the purple band. This is for the general audience who's listening here. But the window to transmit video only exists in a small sliver. You have like 1.3 on the low end. That's going to get you your 420 low frame rate. But it goes really far. It'll push through your house. And on the other end, you have like 6 gigahertz, maybe even 7. I saw 7 gigahertz on FPV, which is crazy, which is like your 5G, right? And it'll get you 12K video, but it's not going to go very far. Right? Those are small waves. You can stop them with a window. In that band is where all communications happen. Your car tire pressure monitor, your Wi-Fi, your Bluetooth, your cell phone, your little Aura ring. Everything is operating in that spectrum. And you have these radio suppliers only working on a small little portion of the yellow band. Some only work on a small portion of the blue band. Like, that's gone. You have to transmit on every band and receive on every band now. And your radio has to do that. Like, that's what I would want as a first principle, right? And these Russian jammers and Ukraine jammers, they'll say, hey, shit, I'm going to take out red, yellow, green, and blue. And I'm going to wait until you're close to me to turn it on. And that's what's currently going on. And that cat and mouse game is playing out. And that's why you see 20, 30 kilometer long fiber optic lines crossing the front line. You can see Mi-8s flying overhead and just glistening fiber optic strands across the cornfields. And that's what's happening, right? And you can go on ChatGPT and say, hey, make me a table of a window of frequencies, the power of those systems, and why it matters. And it will generate that from both sides of the front line, Ukraine and Russia, and their jamming systems. It's pretty straightforward.
It seems to me almost, at this point, almost an antiquated concept to be transmitting on a frequency, or to be even frequency hopping. You're still transmitting on a frequency and then hopping to another one after some amount of time. It seems rooted in 20th century oscillator technology, when we had oscillators that would work on one frequency at a time. But are people thinking about defining, instead of a frequency to transmit on, defining a kind of a diagonal slope that moves across frequency and time, and using that? And then if they're transmitting that way, they might pass through a band that's being jammed for a few milliseconds, but come out the other side and still be able to resolve their communications. With software defined radios, is that a place where we're going, which would define a whole new space in terms of how you're using electromagnetic energy in order to move information?
Well, yeah, but you got to blame analog devices, which 2013, 2015 came out with the Agile transceiver, right? So everything was cool until that happened. And now they're in like hacker RTL devices and what's that little orange guy? Flipper, right? Those are all just analog devices. There's that little chip. Analog devices should probably not sell to anyone outside America. That would be pretty sweet. Just NATO and America. But like, that's what's happening. They're making agile transceivers that are software definable, that allow you to communicate against a wide frequency set. That didn't exist until that time. So it's only been 10 years since that came out, right? And yeah, if you're only, all these radio companies, right, made all their IP outside of an agile transceiver like this, right? Or using an array of them, or seeing ultra wideband jamming. Or they just built their radios around compliance because the FCC only says you can operate in these small, tiny little windows for amateur radio bands, right? So I think that capitalism drives everything. There's a reason why they made these decisions. And I think analog devices SDR, the agile transceiver, has become really popular and commoditized. And you can do a lot of fancy things with it.
Ryan, what does that mean practically if we extrapolate a modern battlefield with hundreds of thousands, potentially even more agents that are deployed, and then you have the classical joint force structure? And up until now, and the doctrine is very disciplined spectrum allocation and deconfliction. And so what does that look like in the world where now you want to, in order to avoid being completely denied, you're transmitting across the spectrum, across all of those bands. At some point, it doesn't become feasible with the scale of all the agents involved. Is there a technology that comes in as a required infrastructure to help manage all of this? Or how do you think that this ultimately gets solved?
I think it's going to be an evolution for some time. And I think, to Peter's point, it's going to be a cat and mouse game for some time. I think that, again, it's the idea of the commercial space eating away aerospace. There's a great company that I met 3 years ago called Distributed Spectrum. A bunch of kids from MIT. They work in Madison Avenue. They hang an SDR out the window last time I saw them. And I won't give away too much of their clues, but they're amazing. And they're a bunch of young adults fresh out of school doing incredible work that vastly is superior to aerospace. And they're using commercial tech. They're using NVIDIA CUDA. They're using inline devices SDRs. They're collecting data. They're putting it together. They're being thoughtful about it. And I think lots of groups like that are going to be the future, where commercial groups and commercial style product development and the speed of iteration is going to allow us to be always leading that cat and mouse game. And the cat and mouse game is played out in the Cold War forever, right? In airspace superiority, we always had to have the F-14, the F-15. Oh gosh, if you ask ChatGPT all the fighter jets that came out in the 70s, it was like the F-14, F-15, F-16, and the F-A-18, or the F-18. That was like 5-6 years apart. Like, that's all the cool posters in your childhood bedroom in 5 or 6 years. I can't imagine how cool that must have been, seeing all those fighter jets come off the line. And you ask, why did we have to make the change from F-15 to F-18 to F-16? Like, damn, there were so many fighter jets. Well, that's happening now with signals, with small drones. And speed and industry need to support that. The same way that we were doing air superiority in the 70s, right? And I think we're just becoming aware, right? And I'm sure in the 60s, there were a ton of people developing their thesis or their architecture or their first principles around what air superiority looked like, whether that be speed or stealth or taking off from an aircraft carrier or being able to land on short runways or having some fighters be there so that they're made for submarine hunting and some fighters there so that they're for strike. Like, there's a whole air superiority thesis that came from the 60s and 70s era. It still lasts to this day. And it's kind of, now we're dealing with the F-35, F-22, and F-47. They're kind of chilling out, right? But it's kind of, they're going to take men out of them, right? And that's the next generation, right? But like, I think that we're in a very fast iterative cycle now. It'll probably mature and plateau in 10 years. And we need to support an industry so that we're the fastest and leading. Same thing we've always done. Same thing we do now, too, by the way. Like, let's not forget Lady Gaga, OpenAI, and Apple. We're pretty badass at it when it comes to it. Tesla, too.
Lady Gaga fan, are you?
No, I'm just saying there's no way in hell China's got Lady Gaga. There's no way. I have not heard one good Chinese song, and I love all music, right? But like, they just don't have that approach and that style and that innovation cycle that demands the best and has that competition, right? We're the very best at that. And I think
I was going to ask you what the drone industry should learn from Lady Gaga, but I'll skip that.
Or we could talk about what the American drone industry could learn from DJI.
Well, okay, so DJI is another topic. DJI came over here. They met up with 3DR, right? And the CCP did something incredibly brilliant. They backed them early on. Around the same time I quit my job and said, wow, drones are the coolest thing ever. I'm going to make my career out of this. The CCP was saying the same thing. First thing they did is they went to Intel's RealSense platform. There's a chip called the Movidius X. That chip basically draws a 3D SLAM map right in front of it. It's an ASIC. It does it all on the edge. Takes 2 cameras, some other sensors like I think it's like a LiDAR unit, something like that, like a TOF camera. Combines it all to a 3D image, 3D map. Awesome product. So they were buying tons of them for their Phantom 4, their Mavic. And they turned around and they said, hey, Leadcore, we're going to buy you. We're going to fold you underneath DJI. And all of a sudden, they have the new Movidius 2 chip, which I more or less believe they just reverse engineered right from Intel, right? So now DJI has a wonderful sensor stack that they use to this day. It's 2 cameras, TOF or a range sensor, and they use it in every axis, up, down, left, right, front, back. And that allows them to not hit trees, right? Awesome vision sensor. And they can even make them on a 250-gram drone. The same sensor stack on the Mavic, same sensor stack on the Matrice, same sensor stack on the DJI Fly Mini, whatever the hell you want. It's an awesome chip. It's made by Leadcore. The next thing they did is they went out to Broadcom and they took that LTE modem. Same thing. I think it's Leadcore, and ChatGPT will tell you. But it's like Leadcore making that ASIC for them. And now you have the DJI 04 unit. Amazing. Crystal clear 1080p video. Prioritizes the center of the frame pixels. So if your video begins to deteriorate, it will deteriorate on the edge of the frame, not in the center. It's based off of LTE principles. But literally, I could put on goggles. I have a 1080p image. I could fly my drone 2 neighborhoods out from my house. And nothing comes close to that. Nothing. It is unbelievably great of a product. DJI's radio transmission industry is incredible. And they CTV backed DJI, and if they've been cooking that for 10 plus years, and they took a bunch of American tech to do it, and they fostered and incubated their drone industry. And that parlayed into everything of all robotics. Now they're making sick actuators. It goes into Huawei with their phones. They have awesome planetary gear motors. Their ability to use NH52S magnets with zero gap, wind them with square wires and dip stators and later stators, like their motors are magnifique. Like every time I get a new DJI drone, I take it apart. It's like taking apart an Apple Watch. And again, they were just today in our internal Slack. We're looking at the manufacturing methods utilized by, what's it called? Unitree. Yeah, so like that dog's arms are fabulous. They have pogo pins or modular board-to-board connections, rigid flex PCBs, locking and polarized pugs, permanent joints, epoxy for reliability, cloth tape on the strain relief for cable bundling, harness routed cleanly and taped down for vibration control. They have carbon fiber extenders. Their motors, their style of electromechanical design, combining electronics and mechanical design together, is the best in the world. And DJI started that. And they beat out 3DR to do it. And they invested into that. And that's all that happened. Right? We still have Intel. We still have Broadcom. We still have Analog Systems. And we have Lady Gaga. So there's not that much land that we lost because of it. Right? We just need to fight hard and fight back. Do what we do best.
Ryan, you mentioned autonomy earlier. I'd like to maybe pivot to that if you're okay. Offline, you mentioned that autonomy is a $5 word. And I totally agree. I think it is a fancy buzzword that gets thrown around too easily, and it has become this catch-all, and it's overused, underdefined. When, in my experience, when I hear people use autonomous, they can mean a PAD loop that maintains altitude. It can be a navigation stack that follows a pre-planned path. It can be even a machine learning model that's making real-time targeting decisions, or it can be full mission-level decision-making with dynamic goal setting. What we're seeing being used in Ukraine is also far from, at least my definition of autonomy, where we might see a YOLO-based detector and then a simple guidance routine that lets the drone fly to those coordinates. It's automated behavior. It's not true autonomy. So I really want to get your take on what true autonomy really means to you. How far are we from those practical implementations of that stack?
It's great. Yeah. I have a lot of new investors who ask the $5 question of how do you swarm? And I think it's such a really good question. If you take a step back and you say, how do you swarm? It's a few different ingredients. The first ingredient, the ingredient that everyone likes to talk about and gets everyone so excited, is the first layer of command and control, right? And we've seen that forever. That command and control first layer, when you have a top-down mission view of all the drones flying around the battle space, and you click them and combine their imagery to get bespoke decisions on the edge. Okay, well, I've seen this since Command and Conquer. I could grab like 8 infantry guys and send them to a base, and there's a basic like if this then that style front-end layer to it, right? So it's a front-end layer. It's like a website. I'm sure there's other things implied there where you can build complex conditional events. I'm sure that you could upload computer vision models. I'm sure you can combine ISR devices and have an automated style of detection of enemy. And I'm sure there's ways to plan multi-agent missions where you're using many devices to collaborate and do one thing, right? I think that's the easiest layer. I think that's software. It's front end. It's user interface, user discoverable, and probably the most commoditized part of the stack. And I think that includes everything from like I don't want to name names, but like there's a lot of startups out there showing the swarm front end.
Lady Gaga.
Yeah, fair. right? But I've seen the Swarm front end so many times, right? And I'm always like, great, that's great, cool. Go ahead, build that. Let me know when you want to plug some hardware in. I think the other hard part of it is fleets and fleets of drones that are ready to deploy and are sleeper and are not in connection at all times with the end user. And we saw the beginning parts of some of that stack, right? Spiderweb. There was cellular-enabled devices being held in a sleep mode, and a set of conditions evoked them to turn on, to connect to an end user, and they were manually flown into targets using PX4, or I think it's even APM, Ardu Pilot Mega, the front end, right? So that was incredible because that was a sleeper cell, sleeper robotic cell that was deployed remotely, and that's kind of like one of the first swarms we've seen. I think the other swarm we've seen is the Shawheads, and they change their style and conditions daily. Sometimes they'll fly very close to the Earth. Sometimes they fly very high. Sometimes they go away from a target and then insert into the rear. Sometimes they loiter and wait for a volume of Shawheads to enter the space and attack at once. And I find that to be really fascinating, and it's pretty rudimentary stuff too, right? Some of it has cellular devices, some of it has SATCOM, some of it has radios, but most of it is on the edge, right? And we haven't really seen any like mesh networking. They don't talk to each other. So I think in the future state, a swarm robotics is a wonderful command and control layer that can do sensor fusion. I think it's a radio layer that is built on cellular and mesh and SATCOMs potentially. But I think most of it is how you build a sizable and replaceable fleet in the tens of thousands that can be used day in, day out.
I agree with you that the near term bottleneck appears to be in hardware, especially in comms and sensing. And oh, by the way, just having the industrial based muscle to produce these systems at volume. But I'm also a little surprised to hear you say that the software element is trivial, because my understanding of the hard part of real autonomy is that this robust integration of perception, reasoning, assurance, and the hard part being the perception brittleness, the uncertainty of decision making, the communications when communications are denied, verifying or proving that systems won't do something
But
that's.
that's a conditional matrix. And we've seen these front ends in front of us before. Like, I don't believe any new front end is going to come out of nowhere to support this, right? And these front end patterns are seen everywhere.
I
There's
mean,
a front end.
is it just the front end, or is there some fundamental technology that needs to be there in order to make these agents truly independent and context aware in their decision making?
I think they do, but I think that has to be pre-programmed. I think some of the first principles that go into this is there are going to be periods of time where you're not going to be in link with a swarm fleet. They're going to have to make decisions on their own on the edge. They're going to have to draw conclusions.
Okay, so somewhat related, but in this context of autonomy and swarming, at a system level, how do you see the balance between hierarchical architectures, meaning a master slave type of architecture, between a central node that's quarterbacking multiple agents on one end, and then on the other end, having a fully distributed, decentralized approach? Are those complementary layers of that same ecosystem or competing paradigms?
I think it's probably the same fundamentals built into that. You'll probably have two different modes, but it's really conditionals, right? Like, we've seen this in software before where you're making a WYSIWYG, what you see is what you get, or you're using a wizard, which is procedural user interface. First you do this, then you do that. So I tend to look at software like that as obviously novel, but nothing like astronomically complex. You're taking a group of assets, you're setting conditionals on them, right? If you see a bad guy, if you're met with certain behavior, then you should do this or that. And I think like if you were to go through user discovery or user journeys, right, you'd be simply left with a few obvious decisions for making and supporting that front end. But it's not like you're building a crazy complex neural net or making the next version of GPT. You're making user interface so that if certain conditions happen on the swarm, they can change and deliver a different condition. So when I take a step back from that, I'm like, okay, that's not like rocket science. That should be pretty straightforward. I've kind of seen these user interfaces before on my Apple phone, right, or on my computer. So I believe that's commoditized. And I believe that sensor fusion is pretty straightforward too, right? Taking multiple video feeds, multiple images, timestamping them, observing those feeds with computer vision models and then presenting conditions and then in turn programming behaviors from that. Like you can do that. In fact, yesterday ChatGPT just made an agent UI where you're basically deploying an agent to do an open-ended project. And it's even Palantir, they have Foundry that works in the same way. So we've seen software that does this. And that should be able to be solved and follow a very standard software paradigm role. I'm not sure how it has to do with the overall battlefield management, right? Like your JAD C2s. But like, how do you swarm? That layer doesn't really scare me the most. I think the Shahid effort, right, is they've weighed heavily on industrialization. Again, buying your own Shahid in Alibaba is very easy. It'll come through in USPS mail. And they make them everywhere. And they're built to be deployed with arsenals all over the place. So like I think the weight there goes into what are we building 50,000 of? Where are they being deployed from? How are they kept alive for software updates? And what's that long strategy to industrialize around that asset? The software is, I think, just the stuff that people find sexy and they want to talk about and it's easy to bet on because it's straightforward or you can make sense of it. But again, I think we've seen that since Command and Conquer and StarCraft days, right? It's nothing like crazy in my behalf.
Ryan, congratulations around all the success around the C100. Tell us a little bit about the process of winning the contract. And also, I want to ask you a little bit about how did you develop it? I mean, you work hand in hand with the military in developing what you do. Love to know from the very beginning, how did you develop that capability?
Yeah, so PDW has a long history where we spend meaningful time with veterans and SOF operators to develop our products. Today, our CTO, Dylan Ham, came from the SEAL teams. Our head of R&D and our head of revenue are also SOF veterans, and our leadership team is like 60% veterans up. So at the end of the day, the user is a highly specialized person who has a highly specialized, operational environment, right, that we're trying to meet. So the C100 was simply a drone that we saw market availability for. We saw procurement and the need as a way to generate capital. Our first drone that we made, though, was an FPV drone that had a Picatinny rail and was a thermal camera, and that was done in 2016, 2017. And we knew that because we knew Dylan and we knew what he was deploying with, which was his own assets, because he didn't like the Switchblade at the time. That's almost 10 years ago, right? So I think that there's two things. One, we know what the future's going to be, and we're very excited to work on it. But there's also where is money being spent? And that's being spent on things like SRR and MRR. For us, MRR was a much easier market. There's not a lot of competition. You have these really old primes like FLIR and Lockheed making tons of money on old-fashioned products like the Indago and the Skyraider. So essentially for us, we're like, okay, that's a safe bet. Let's build toward that area. And I think the other thing about the C100 has a lot of different segments and customer markets, right? So we have a bunch of them flying around POTUS looking for bad guys in golf courses. But they're also used across the TIC brigades, SOF forces, Texas DPS. So it's just a huge TAM for us to and make money, right? And I think all around it's a great product. It's a great camera drone. It can drop munitions. It can do SIGINT with a khaki Mastodon. Today, we were doing cross-domain precision fires with fighter jets out in Europe. We were doing cross-domain precision fires with the F-35 a few months ago, hitting targets with glide munitions. And it can serve a lot of different needs. So we designed the C100 backwards from a soldier's rucksack, literally bought the biggest rucksack and then measured the propellers backwards from that. And then everything really fell according to that. Our payload size, the dynamics of the aircraft. And we undersell it. That thing will fly in 55, 60 mile an hour winds, but we tell the customer it's 35. It can actually lift 15 pounds, but we tell the customer 10 pounds. And we just work really hard to have a good price point, to support the customer. We knew if we leaned in hard on the mothership, Baba Yaga today, it was going to provide value. And as a company, we're able to focus on that product. We're not distracted. We can build into a nice business and get ready for all these curveballs and the speed and iteration that we see today. So in essence, Mothership, or C100, is the first of our cargo series of drones. We'll have a C50, we'll have a C25, that's a 5-pound and 25-pound variant of that asset. And we want to corner the market on motherships, multi-mission style, and fight hard for that heavy set quadcopter that holds $100,000 payloads and never falls out of the sky and is reliant. I think on the other hand, it gives us room to really push hard on FPV, what we believe is the master thesis for what that product will be. And our FPV is different from everything else out there. Not only the way that it's manufactured, but injection molded and no harnesses and no soldering and putting it together like Legos, but it's a real combat system. The core body is just a body with no arms, no motors, no payloads. It has 7 different payload slots, 4 for the arms, 1 for the camera system, and then 2 for munitions and power. And depending on your mission set, you click in your stuff just like you would in M4, and you go out on your mission. If the drone falls down, you can fix it. If you want to switch from an EO to an IR payload, you can do that in under 10 seconds. If you want to switch out the drone arms from a big drone arms to a small drone arms, you can do that in under 5 seconds. If you want to put on a new radio, you switch that in, switch that out in a couple seconds. If you want to put on a shape charge to an anti-personnel charge, that's a couple seconds. And it's also made with a high voltage fuse and uses encryption. So we're meeting the standards of safety and security to our end user. And it's very different from using a couple of carbon fiber plates with some 3D prints and some COTS components. It's a fully integrated, vertically designed product that should compete very well against the Javelin and the Switchblade. And it's edge enabled too. So you can throw a computer vision model on it, it can fly itself, you can swarm with it, you can intercept with it. It's really our purpose-built attributable system multirotor, right? We call it the AM10, the attributable multirotor 10-inch. We also sell a 5-inch and a 7-inch, and eventually, I'm sure, we'll go up and down the line and compete on that non-exquisite throwaway style quadcopter that can strike and loiter and swarm and intercept, and that's what we're building for.
You just went through a long contract process. Describe for our entrepreneurs who would love to win similar size contracts. Give them some lessons learned that you've took from the program.
So just know it's going to be a really long journey and prepare for it. And cash flow is really the name of the game. For us, I think the first lesson is working with veterans is a huge important part of product development. Not just sales, but how you make your product. The leader of our product design, our CTO, who's in charge of everything from requirements to engineering, is a Navy SEAL. And I've spent my whole career in product development. I've worked on, one of the first things I did was the BMW website in 2006. I worked on the JCPenney women's line. I worked for McDonald's and Colors and MLB and all these different companies and making stuff for them. And this is the most different user I've ever seen by far. And they have requirements that I would never even realize. And I didn't really understand that until I started working with Dylan. And it kind of dawned on me, and I was like, my gosh, this can only be done through the eyes of a warfighter. And I think that's the biggest cheat for us. It's just leveraging veterans, putting them in high executive positions, allowing them to make big decisions, right? And that was critical to the success of designing our quadcopter. I see a lot of quadcopters out there designed by civilians, something I would have done alone. One of the first things I saw was one of the first demos I had was with a soft group. They put the drone in a hover, they took out an AK from the back room, and they walked away from the drone with the AK in the air. And they only cared about how far away they could see a bad guy's gun. And I couldn't believe that. I was like, oh. So the whole gimbal we picked was wrong because the IR requirement wasn't there. And that goes into everything. There's so many different tiny little caveats and things like that you can learn through the eyes of an operator. So if you really want to be an expert in the subject, find someone who's been at war. Find someone who knows how important it is and that there's life depending on the success of it. That just becomes your culture and your backbone. The second thing is cash flow. It takes a long time to get your first check. And the growth curve is slow and short and then very fast. So we built slowly, starting in 2017. I had a handful of people who I worked with, but it was skeleton crew for a long time until we really started to meet traction. And we had our first manufacturing line was in the woods and backwoods Huntsville, Alabama, where we had enough property to fly aggressively all the time and manufacture next to it. So we had a manufacturing line in this super backwoods retrofitted barn. It was sealed, it was clean, it was AC. We had electrostatic discharge floors, but it was in the middle of nowhere. And we would manufacture a drone and fly it, and we'd have our demos there, and we'd make changes on the line there, and we brought our engineering to sit there, and it was a cohesive team for a while, right? Getting our first boards out the door, finding faults fast. I think when we first started selling drones, we would fly the drones for like 10 hours each before we gave them to a customer because we were so paranoid something would go wrong. And then, yeah, you got to show up everywhere. We were at AWE, we were at Vertex, we were dropping bombs way before it was cool. And I think showing up at exercises and failing in front of a customer and showing them prototypes, as damning as that is and as shitty as it is to lose a few days in backwoods, in army bases and everywhere else, sitting and waiting for your time to see if you can make it or not, and going out on a limb, it shows a lot of trust with the customer. And I think that's a core part of what makes us successful. We are always out there with the customer, and they see the effort and the change over time. And it's a long relationship, and there's a lot of trust there. You are making weapons that can determine the livelihood of somebody, and we take that really seriously. But once you're in, it is by far the coolest job you can have. I can't believe I'm in this space, and I get to work with these people. And I came from Manhattan, a TV show for kids, flying all over the world with colored drones, and this job puts that to dust. It is so cool and so important and has purpose and meaning behind it, and I get to work with all these crazy cool guys, right? So it's definitely worth it. And I think we're at the foothills of a lot of growth. So if you're out there saying, can I get a drone? Can I go in there and compete against the C-100? Absolutely. It's the early days of this. And we need tons of American entrepreneurs in this space. It is about to explode. And you can see evidence of that everywhere. I just be real careful because it's different than the other startup. You have to be really smart with cash flow and got to get your hands dirty. But it is the most rad and cool industry to be in, and it's time to disrupt and shake up things. And these primes, those guys wearing those khakis and drinking white wine, it's time to shake them up and show them what commercial American tech can do.
That's very inspiring. Thank you for sharing that story, Ryan.
Yeah, of course. There's a room for a lot of competition. I don't see any of it. There's us, there's Neros, there's Firestorm. I really like Mach Industries. Ethan's cool. Soren's cool. Dan is cool. And there's a room for a ton.
Orca in Europe.
Yeah, Orca in Europe is very cool, right? There's just room for tons of American growth, and the customer is going to be there to support you. And I think that you just got to read it in tea leaves sometimes. They're not very forthcoming with announcing. Like, they're not going to have a WWDC and tell you all the jobs are coming and all the potential. But, like, sit on ChatGPT, look at Hess's memo. It's old school military doctrine written from veterans who have risked their lives. And it's a very orthodox space to be in, very orthodox, but it's time.
Maybe as a final question, where would you direct innovators and entrepreneurs to go and build next? What corner of the technology or capability do you think deserves focus and attention today?
Radios, signals, motors, planetary gear motors. Where's my four-legged robot that costs $5,000 from Amazon? Come on. I think that there's space in maritime, submersibles. I think that there's shipbuilding to be done, fixed wings, spaceships, balloons. Everything is about to change. And it's just glaringly obvious. And I think there's a huge movement on Twitter and reindustrialization and tech, and deep tech, and all the cool people are living in El Segundo. And I think the whole thing is open. It's just getting started.
See, not even 90 minutes was enough for our conversation. I'm sure we could go on for another 90.
Yeah, I'm down for another one.
Cool. We'll have you back at some point. Guys, anything else that we should ask Peter, Jim?
Good. Thanks, Ryan.
Yeah, of course.
No, this was a great discussion.
Yeah, really appreciate the time, Ryan, and the insightful conversation.
Yeah, absolutely. It's a pleasure.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.